My name is Henrika Makulu. I did applied maths at NUST. Uh, you will know very soon when I graduated and so forth. I'm currently a data analyst at Cassava Smart Tech. For those of you who don't know Cassava Smart Tech, it is the company that holds EcoCash. So it's a Strive Masiwa company that it was birthed from Econet Wireless. I'm also the founder of a company called HM Digital, which provides data analytics training to different people, as well as mentorship initiatives and providing data services to clients as well. So that's me in a nutshell. Today's agenda, we will look at 4 things. The first thing is that I'm going to share what my time at NUST was like. Very interesting journey that I had while I was at NUST. Secondly, I will share with you what are your career options as someone who's currently studying maths or statistics. What are your career options that are out there? Thirdly, you'll have the privilege of having a day in the life of a data analyst myself. What is it that I do on a day-to-day basis for Econet, for Cassava? You will get to see that firsthand. And then lastly, we'll just look at some tips and tricks, things I wish I had known when I was still a student, or things I've learned along the way that I would encourage you to apply. Okay, so let's go straight into it. So I'd like you to walk with me. My time at NUST began in 2007. That shows you how old I am. How did I end up doing applied maths? To be honest, at that time, I had no idea what I wanted to do. When I was filling in the form for university, I was confused. So I just looked at the options and I looked at what I had passed in A level, and maths was one of my strong subjects. So I just ticked maths. And in fact, maths was my second option. I first ticked sports science because at that time I was a tomboy and I was all about playing sport and managing sport and all that stuff. But unfortunately, when I then got to NUST, they said because I didn't do A-level biology, I couldn't do sports science. So they gave me my second option, which was maths. And my first 2 weeks, I was actually in denial. I did not want to do maths. And I used to go to the sports science faculty and act like I'm a sports science student. And I would keep going to their offices to beg them to be part of their lectures until one day, I think it was the chairperson of the faculty said, look, young lady, you are not in sports science. Go for your maths lectures. And so I had to go for my maths lectures and I didn't know why I was there. I was really confused at that time. Something else happened during my first year. I had my first and biggest heartbreak. Yes, it happened while I was at NUST. And so that's how my NUST journey began, with this bad news that I'm telling you. The next year in part 2, it wasn't easy. I had failed my part 1 mechanics. End of part 2, I also failed the part 2 mechanics course we had. And so, like I said, my maths journey didn't start on a good note. I used to walk an hour from Sunninghill. I used to live in Sunninghill to campus. And by the time you get to campus, you would have eaten at home, but you get there already hungry. You'd have walked from 7 a.m. to 8 a.m. If you had bathed, your feet would already be dirty. It was just a long walk from where I stayed. I'm sure some of you might be familiar with that for those of you who've lived near those areas. I also happened to be at NUST in 2008 when things for us as a country were very, very tough. So we also had food issues. Those are the days we had food shortages. And it was crazy. The shops were empty. As students, I think those days we mainly used to eat chunks. And there's nothing wrong with chunks, guys, but chunks are nice when it's your choice, when that's what you want to eat, not when that's all that's there the whole semester. So it was tough. But we moved on, and I also had accommodation issues. I remember once walking around Riverside, Selborne Park, knocking door to door, looking for a place to stay because campus accommodation was full. And it took a very long time for me to eventually find proper accommodation. So that was my part 2. When it then came to attachment, I went for 4 months without attachment. Eventually, 5 months after waiting and applying, I finally got attachment at a company that used to sell educational software. And if I tell you, during my attachment, I was pretty much a receptionist. I would just sit at reception, man the reception. And really, it wasn't really anything related to maths. But you will know after this presentation how you can take things like this that might not seem related to what you're studying. How do you then use that situation to your advantage? So that was my attachment here. And then what happened in my attachment here is that when I was now preparing to go back for part 4, I was then told that you cannot proceed to part 4 with a part 1 carry. And I still had not rewritten my mechanics. I had written it twice and failed twice. So I didn't go the 3rd time. And now the university was telling me I could not proceed to part 4 because I still had an outstanding part 1 carry. So that was very disheartening. But unfortunately, I had to accept it. So I ended up using my 4th year of university to just write 2 courses, mechanics part 1 and mechanics part 2, which I had failed. So I literally spent a whole year just doing 2 courses. And it was so disheartening looking at my classmates moving on with final year and me having to repeat and then having to do my final year the next year. So that's how my 2011 was. I also struggled a bit with school fees. I wasn't able to pay all my fees, so that also drew me back on some of the semesters I was supposed to do. So it put me a year behind my studies. So unlike the standard 4 years, I ended up taking 5 years in my degree. 2012, I had my dissertation, my project. When my colleagues were on chapter 4, I think, I was still on chapter 1. And I was having challenges on my chapter 1 and things were just not working well. And I really thought I was not going to submit because when my colleagues were wrapping up and they were now on chapter 5, I was still struggling with my chapter 1. And I almost thought I wouldn't graduate again in my 5th year of being there. But it worked out in the end. I also sold sweets and jiggies, chips, in class to make money for transports and all sorts of things. So I really had a tough journey when I was at NAST. But some of these challenges are what, makes you who you are. And I'm glad to say after 2012, it was all over. I graduated in 2012 and I got an admin job where I basically used to do data capturing, filing, and so forth. And the reason why I share this is because in Zimbabwe, jobs are tough to come by. So don't think that your first job is going to be as a programmer or an actuarial scientist. You have to start somewhere. So even if you get a job where you're filing, like I had to do, accept it. Don't be picky at the beginning of your journey. Just accept it and be the best person at filing such that people know this person has a math degree. But whatever they do, whether it's filing or whatever, they're just so meticulous and so thorough. And for me, that's what I did. I would file, I would capture data at this company. And I got promoted 3 times at that company because of how I was thorough in what I did. So that's just an encouragement to you as well. I stayed there for 5 years and I eventually grew frustrated because I was saying, I'm someone with a maths degree. I did hard courses like calculus and linear algebra, but I'm here filing. and doing all sorts of things that are not really challenging me. So I grew very frustrated. And I then decided to start taking some courses online. I first had to ask myself, okay, what is it really that I want to do? Because even at this stage after graduating, I wasn't really clear, what can I do with a maths degree? And eventually I stumbled upon the word data analytics. And I started researching online, what is a data analyst? How can I become one? And it showed that because I had maths, my chances of getting in such a field were really high. So I began to teach myself data analysis or analytics online. And I started to do up my CV. I started to practice some data analysis on some of the things I was working with at my current job. And one day, I had registered myself on CV People on the internet. And there was an advert that Econet was looking for a data scientist. Now, I had heard the word data analyst, but not data scientist. So I started Googling, what is the data scientist? And I decided, oh, well, let me apply, even though I have no idea where to begin. I'm so not experienced. And so I applied through CV People to Econet. I got called for an interview. I went to the interview. It was a very technical interview, which I felt I failed because all the technical questions they were asking me, like, how do you build an algorithm or how do you build a model? I had no idea because, yes, I had done applied maths, but I had never experienced anything after university and I really had no idea what I was doing. But I convinced the interviewer, who is now my boss, that, you know what, I'm very passionate about data science. I've Googled it. I'm willing to learn. I'm a fast learner. So I don't know much, but I'm passionate and I'm willing to learn. And that was that. I thought I wasn't making it. And I was then called to a second interview, which was a practical. Now, at this practical, 5 of us had been shortlisted. And the other 4 people had master's degrees. I still till today, I don't have my master's. So I was very worried and I thought, obvious, one of the 4 people with the master's got the job. I don't have, so, and the practical was very hard. It was a practical in SPSS. And I had done SPSS a little bit during my applied maths degree, but I hadn't done much of it and I was rusty. But I remember for one of the questions, I actually went to the question mark, the help function on SPSS. And I asked, we were supposed to create a variable or something. And I actually typed on the help, how to create a variable. And it outlined the steps, and that's what I did for my practical. Long story short, I was called back and I got the job. And I'm actually grateful because they began to train me from scratch. So my first day of work, they were actually telling me, this is how you do this, this is how. So I didn't even need to have known everything per se, but they taught me from scratch. I went through training on how to be a data analyst. What happened is, because I didn't meet the qualifications of a data scientist, or the experience rather, they then, instead of giving me a data scientist position, they gave me a data analyst position. So yeah, that's how I started working for Econet. I was really excited. I was training on being a data analyst. And finally, after 5 years since graduating, I was finally working on things that involved maths, things that involved analytics, things that excited and challenged me. And then in my first year of working at Econet, I got the opportunity to work in the office of the Chief Operating Officer, Mr. Fayaz King. You should Google him. He is an exceptional man. He's now actually gone to the United Nations to be the Assistant Secretary General, working in innovations and so forth. So I got to work with him for a year before he went to the United States to work for the United Nations. And the experience working with him was great. This man is really good with numbers. And I, as an analyst, had to help him make decisions for the business based on what the numbers were telling us. And it was really exciting. I learned so much from this man. He mentored me, which is why I am now passionate about mentoring other people because of what I gained from him. Also, while I was working in my first year at Econet, it so happened that they wanted to hire another data analyst. There's a department that needed a data analyst, and they had liked the work I had done for them. So they said, can you help us interview for another data analyst like you? And it so happened that one of my prior classmates at NAST came for the interview. And he was in my original class where I was supposed to graduate first, but then remember I repeated and I now graduated later. So he was in my first class, and this guy was exceptional. I think he used to get distinctions and so forth. And now here I was interviewing him. And that was just a great experience to know that, your results at NAST don't really define your place later on after university. So yes, you want to do well at NAST with your degree, but just know that that doesn't define you. In 2020, fast forward into 2020, I started a company called HM Digital, where I've been training people in digital literacy, data analytics, mentorship, so forth. And I think I've had 7 paying clients so far. So that's been exciting. Last year and this year, I've been able to train and mentor hundreds of people because of the experience I now have as a data analyst. So that's where I am now. And I just wanted to share my story with you. And for those of you who believe in God and love God like I do, I just put a verse there that has really encouraged me throughout my time, that in all things, God works for the good of those who love him. And for me, that has been true, because look at all the negatives that I've shown you throughout my time at NAS. It was just negative after negative, but God turns those things into good. Okay, so that's my story. I enjoyed sharing it with you. This was when I was, I think, in part 2 with my friend Liz. I think we were the only 2 girls doing applied math. So yeah, it was very interesting. And then I used to play basketball. So I used to work hard and play hard. There I am in the frame there. I used to enjoy playing NAST basketball. Then, guys, these were the hard days where food was a big issue. And when I look at this picture, I laugh because I just look like I was suffering. And like, this was one of the best days where you've just gotten pocket money and you can afford, I think it was $1 or $2 for sadza, and you go and get your sadza, and it was actually a luxury back then. So it was fun remembering that. And I don't know how many of you know the matrix of eating at NAST. I don't know if it's still like that these days. But when we were there, we used to say there's a matrix where if you eat breakfast, it's a 1. If you don't eat, it's a 0. So if you had breakfast and lunch, it would be 1, 1, and no supper, 0. So we used to laugh and say some days it was 0, 0, 1. You only had money for supper only. Or some days it was 0, 1, 0, lunch only. It was never 1, 1, 1 those days. 2008, you wouldn't have breakfast, lunch, and supper. It would either be 1 meal a day or 2 meals a day. So these were those days, and it's been fun remembering that. And then finally, I got to my 5th year, and I was finally graduating. I've blurred out the faces of the people there because these are now big, important people. I have to ask for permission to use their faces. So there I am with my cascade. At least the guy next to me could afford a Fanta. I was there with my cascade. But yeah, it was finally good to graduate with a BSc honors in applied mathematics. And let me tell you, when you then say that in the world, people are just like, wow, maths or operations research. So I'm sure you'll enjoy, once you've graduated, saying, I have a BSc honors in statistics and operations research or in applied mathematics. So just to inspire you. Okay, Then a look at now, where I am now, just some highlights of some things I am grateful for, that I've been able to get a lot of data science certifications online. I have 6 years experience in data analysis. I've trained over 500 individuals in various skills. I've created automated dashboards. I've trained government officials on how to use analytics dashboards. I've trained South African teachers online. I've founded a mentorship program. So this is just to encourage you to say life may be tough in university. And maybe for you, it's actually not tough. Maybe it's fine for you, but there's so much that you can then do later on. You just have to find what you love and get into that. Then just a fun exercise. For those of you who have data right now, please go to www.menti.com and use the code that's there and enter what do you want to be after your degree. Enter and we'll see the results live. Okay, so far, majority of us want to be analysts, which is great because the field of operations, research, and statistics, as well as math, is very numerical and has an analytical application, so that's perfect. Okay, moving on. So what are your career options as someone with these numerical degrees? So the good thing about applied maths and operations research is we can apply maths and we can apply operations research to literally any industry. The main ones that people often get into are banking, the health sector, insurance, tax, investments, that's all finance sector, trading, stock broking, engineering. We have a lot of maths people who get to engineering, which I found really strange because when I was at NAST, there were all these engineering degrees. But it's crazy that even with your maths degree, if you then decide you want to be an engineer, you can. That's how diverse these fields are. A lot of people get into actuarial work, which is the same thing. There's a degree in actuarial science at NAST. But if you do applied maths or operations research, and you now decide later on, I want to be an actuary, you can totally do that because there's a lot of overlap in our applications and our field. Others get into accounting, economics, operational research, market research, pensions, retail. The list is endless. And I've put a picture of this on WhatsApp for those of you who are on the group, so you can keep this with you. My point here is that you can be in any industry because all industries need analysis done, and maths and operations research do that. In terms of professions, you can be an actuarial analyst or an actuary. You can be an astronomer. The sky is the limit, guys. It would be great to have Zimbabwean astronomers out there. You can be a chartered accountant. You can be like me, which is a data analyst. And please note, I only learned about data analysis on the job in my first week of my work as a data analyst. That's when I learned what I actually do. So you don't have to know everything beforehand. You learn as you go. You can be a data scientist. We'll explain the difference between data analyst and data scientist later on. You can be an investment analyst, a research scientist, a lecturer, a software engineer, sound engineer, statistician, mathematician. Guys, if you as an applied math student or an operations research student decides after graduating you want to be a lawyer, you can do that. Literally, you can learn anything because what this degree teaches you is critical thinking. So you are now in a space where you can learn anything quite quickly. So you can literally change at any stage what you want to do. So this is to show you how many options you have. The list is endless. I just put these, but there's still more. So be encouraged by that. Then I wanted to talk a bit about the technology sector, the technology world. The world is moving fast. If you think back 5-10 years, the phone you had tells you that we are moving fast. Phones are changing. The fourth industrial revolution is here. So careers are different. you need to be future ready. What do I mean by this? Currently, I've been working from home for the last 1 year. And for our company, we're not going back to the office. It's permanent. We're working from home. If you are not able to technologically advance and deliver work remotely, or even you guys, I'm sure now you're schooling remotely as well, you'll be left behind. So technology is very important. And if you want to be an operations researcher or applied maths practitioner, whatever you are, who is relevant to the times, you can't do that without technology. So our fields and technology go hand in hand. We have a lot of self-service these days. I remember when I went to South Africa or at Tambo International Airport, you can literally go to the machine and check in without seeing a human being. You've checked in, you're done. We're moving fast. And so a lot of these things need technology. We've got artificial intelligence, self-driving cars, robots, drones, all those things. These are places where applied maths and statistics can be used. So if you're interested in technology, the options are limitless for you. We are now in the big data age where we are seeing big data. We'll explain what that is later on. We're moving to the cloud. Google, for example, now keeps your photos if you have Google Photos. And I have photos from, like I'm saying, when I was at NUST. Literally, Google has your life. So everything is now moving from hardware to the cloud. We're getting 5G coming in where we're going to have crazy internet speeds on our phones. Someone was actually saying we might get to a stage where network will bounce from phone to phone. You won't even need network infrastructure anymore. So we have so much technological advancement. And lastly there, I just named some big powerhouses in the world that are using tech and using big data. You've got LinkedIn. The way LinkedIn recommends to you to say, you searched for this person, here are similar people. That's all data that's being used in the background. YouTube, when you watch a YouTube video, YouTube tells you, you watched this video, here are some similar videos to that one. Netflix, same thing. Amazon, same thing. So this is now me getting into how much data is out there. Data is simply information. Any company that keeps a lot of information can use our skills as people who know how to work with numbers. So if you're into tech, please consider these fields as well. Okay, so we're going to get into a quick exercise. I'm not sure how many of you saw on the WhatsApp group. I promised prizes. So I've got 2 prizes. For 2 people, you can raise your hand, please. The first question, so if you get this question correct, I will give you a prize. My first question is, can you define 4 terms from the terms that are here? The second question is, what is the difference between data science and data analytics? Okay, well done, guys. I'm actually quite impressed. When I was in my final year, I had no idea what these things were. Like I said, I learned them on the job. So just to clarify, business intelligence was defined correctly earlier on as a process where you're using analytics basically to inform a business decisions. I'll give you an example. For EcoCash, if we are saying on a daily basis, we want to know how many customers we had and are they declining day to day or increasing? That's the use of business intelligence. Big data is not just the volume of data, because you can have lots and lots of data, but also the speed with which it's collected. So we have what they call the 3 V's, the volume, the velocity. So the volume is how much data, the velocity, how fast it comes, and the variety, the different sources of data. So that's big data. I've heard a lot of people saying big data when it's actually not big data. So it's good to know the technical terms. Machine learning is like, I think it was Tabo correctly put it, it's when a computer is learning to do what a human being does, or learning patterns. For example, you can feed pictures to a computer, and you can tell a computer that these 3 pictures are pictures of a cat. These other pictures are dogs. When you give it a new picture, it must tell you whether it's a cat or a dog by comparing it to what you would have shown it before. So it's like a machine learning patterns as it goes. Artificial intelligence is when a computer is doing or a machine is doing what a human should do. For example, self-washing taps. When you put your hand out, the water comes. It's got sensors. Previously, you would open the tap, but now it's sensing you are there and the water comes out on its own. Or self-driving cars, that's the use of artificial intelligence. Algorithms are basically, how do I explain it? Methods or formulas that are used in a computer to solve a problem. So for example, I could say, I want to find out if there's, if I have a certain product, which customers are going to take up this product. Then I look at my previous customers and the characteristics they have, and I feed data from my old customers to in code. Okay, algorithms are coded. Then the code or the algorithm can tell me, based on the past behavior of this data, these customers are most likely to leave your product or to use your product. Then I'll leave the last 2, data science and data analytics. There's a big difference, and you have to know the true meaning because you can't just throw the terms around. I've heard a lot of people using the terms but not knowing what they mean. Data analytics is, I think, like Becky Nkosi said, the use of graphs, patterns in data, processing of information to visualize it and make decisions. So when you create a graph in Excel that is showing you a pie chart, that is data analytics. A pie chart that's telling you 40% of the population is male, 50% is female, or whatever it is, that's data analytics. Data science is data analytics plus using algorithms or using machine learning to now predict future events. So data science is basically data analytics with coding on top of it. Okay, so because of our time, I'm going to have to move on a bit quicker. So those are the differences there and the definitions. Okay, here I'm basically trying to show you how, if you become a data-driven person, you can help companies or individuals make decisions using data. For example, we have that paragraph there that says, from January 2020 to date, we have managed to service 50 clients, almost half of whom are in the food industry. This is a decline from blah, blah, blah. I'm even tired reading it already. This option A can be represented fully by option B there simply by using data. We've simply said 2020, we had 50 clients. 2019, 56 clients. Therefore, in 2020, there was a 17% decrease from 2019. YOY means year on year. These are some of the terms we use in industry. Year on year, 17% decrease. And you can then see a graph there of the different food industries. So basically, you can use data to quickly tell you and summarize a story that could have been many lines. And this is what we want to do as applied mathematicians and operations research statisticians. You want to get to a company that has all these words and paragraphs and be like, guys, can I change our reports? We now use figures. Just that simple change will help your company make big decisions, and you now become relevant in your industry. Then for those of you who are interested in becoming data analysts or data scientists, like myself, I encourage you to datacate yourself. These days, life is very simple. You can simply learn data analytics by watching YouTube videos. How do I start my first data analytics task? YouTube will tell you. LinkedIn, if you follow me on LinkedIn, you'll see I write articles on how to do some of these things. I also do a lot of courses on IBM Digital Nation. So if you go and check out their courses, they're really good. I've benefited from them. We also have Coursera, Udemy, Dataflare, DataCamp. If you visit their websites, they have a lot of courses on data analytics and science. Kaggle is a platform if you want to be a data scientist, for example. They put real life problems there and you solve it. And if you win the competition, it puts your ranking higher on the platform. So even if after graduating you don't have a job, you can register on Kaggle and practice and teach yourself data science, such that when you're now job hunting, you can say, I've completed 5 Kaggle projects. So you now have that experience without having a job. It puts you a cut above the rest in terms of finding work. The tools we use in data analytics and data science, Excel. In my first year, I actually used Excel only. So you mustn't think it's something complicated. You can get away with Excel if it's the beginning of your journey. But you want to advance and use tools that are quicker and better. So we also have Power BI, Tableau, and ClickSense. These are called visualization tools. You can look them up afterwards. And then programming, Python and R programming. Guys, I regret not paying attention to programming at NUST. When I was in part 1 and part 2, I think we did some programming courses. I wasn't even paying attention. I just wanted a P. So I wasn't even trying to understand what I was doing. But I would encourage you, coding is getting really big in industry, especially if you are in a numeric field like ours. So try and learn Python. Python is okay, it depends. Some people say Python is easier, some people are. I personally use Python. But R is very mathematical, which is also a good thing. And then also learn things like SQL. Okay, so coming to what my job looks like. We are now rounding up to the end, so I hope I'm not going too fast. In my job, I come across a table like this that I extract, and it will show me the number of transactions. By the way, this is fake data. So don't think you now know all my company's secrets. So I'll check to say, okay, this is the table we have. But obviously looking at it like this is a bit difficult. So I'll create graphs. Like I said, if it's your first year, you can even use Excel. So I'll create graphs that will show me that on Friday we had higher transaction amounts. And then I'll use different graphs for the same thing. So this graph is a bar chart. I'll also use a line graph for the same type of data, but just to see the data differently. Then I'll also use, oh, sorry, I just put 2 for now. So you can use different graphs to visualize your data and it will help you make decisions. So based on this, you then create a report that says, our sales on day number 7 are really low. We need to check what's happening, or we need a campaign to increase sales. And you then become a person who's informing business decisions by analyzing data. So that's what I do, my day-to-day. I also use SQL to code, to extract my data from the business system. So we have keywords in programming. SQL or SQL uses words like select, where, if, from, and. So let me show you an example. If I say select all, it will select all the columns of this table. From, you have to name your table. Let's say your table is called transactions. You then say from table name, whatever your table is, where day equals Saturday. So just with these 3 lines of code, I can extract all columns of this data where the day is Saturday. So it will then extract and give me a table like this. So as a data analyst, you also need to know how to do data extraction, which is the process I've just shown you now. But I also use Python to do my, my data processing. So Python also uses keywords like import. Import here, just bringing in the Python libraries you need to conduct the task you want. pd.read Excel means we are reading an Excel file, and then you put your Excel name there. Head means you're asking it to show you the top rows of your data. Describe means it will show you the mean, the standard deviation, the minimum, the maximum, and you can therefore analyze your data. So give yourself a hand. If you had never conducted a data analytics task, you have just completed your first data analytics task. Well done. So that is what I do in my day-to-day job. And then I just want to end by giving you some tips and tricks I've learned along the way. The first one is, whatever you do, do it well. Like I said, I worked in where I was filing. Someone with an applied maths degree, but I was filing. I could have just said, this is boring, this is not my job. But I did it so well that I then got promoted. I went up the ladder up until I was able to get a relevant job. So whatever you do, do it well, even if it's making tea. Some of you will get into attachments and you'll just be used as the tea girl. Do it well so that you leave a good impression and you create relationships and you gain experience. Secondly, find what you love. For me, I love organizing things, which is why data analysis works well with me, because I am very organized. I love speaking, which is why I'm speaking to you guys today. So I like taking data and talking and presenting results and presenting findings. For me, that's what I love. What is it for you? Do what you love. Look for people who represent the you that you would like to be. Go on LinkedIn, go on various platforms, follow people and see what is it that they do. If you want to be an actuarial scientist, look for the best actuarial scientist in Africa. Follow their quotes and just see what they do. Fourthly, success is the sum of small efforts repeated daily. Guys, I can't tell you how, like I'm saying, I spent 5 years doing an admin job. Now I've been 3 years doing an analytics job. You can't get results overnight. Be patient with yourself, even if it means doing something small every day towards your goal. For me, for example, when I was learning Python, bit by bit every week, I would do maybe 30 minutes, 30 minutes, 30 minutes until you learn. You don't have to say, I'm doing 3 hours today until I finish. Success is the sum of small efforts repeated daily. Be a problem solver. When we're at university, we think it's about finding a crazy, complicated statistics job or maths job. But let me tell you something. If you go and work for, let's say, CBZ or whatever company, and let's say currently they have manual processes where they fill in forms on hard copy, and you come up with a system where you can do it quicker and easier in Excel, you've solved a problem. So when you start your journey after graduating, be a problem solver. Don't worry about starting with the complex things. Solve the problems that are in your business. People will thank you for it, and that's how you get promoted and so forth. Start with the basics. You cannot be a data analyst using Python if you don't know how to use basic Excel. Start with the basics. Learn the simple things. Do all your things bit by bit. And then network. Reach out to various people. I was looking at my sent items in my Gmail, and I was seeing that when I graduated, I sent an email to, I think, 10 people saying, hi, I've graduated. Here's my CV. I'm looking for a job. And how I got my first job was because I told someone at church that I was looking for a job, and they found me a job. So don't be afraid to reach out. Most jobs are got through connections, not to say through corruption or nepotism, but simply by giving your CV to people you know who can spread the word about you. Then don't be afraid to mentor and teach others. Probably there's some O-level students who need help with O-level maths, and you find it easy. There are lots of people who are CEOs, and now they're doing an MBA. Now they're doing an MBA and they've got a statistics course. For you, statistics is easy. Help them out, because the more you teach, you're also learning and cementing that knowledge in your head. Then, like I said earlier, it's okay to not know what you want to be at this stage. So don't be hard on yourself. The internet is your friend. Google what you need to, YouTube what you need to. Try things out. Some things work, some things don't. Our fields are such that we make many mistakes before we actually then figure something out. Another way to succeed is to copy and paste what is working elsewhere. If you see something that someone else did in America and you're the first to bring it to Zim, that is also innovation. So copy and paste what's working elsewhere. Measure your impact. I have an Excel sheet that I keep that shows me what I have achieved from the time I started working for Econet. What change did I bring? What problem did I solve? That way you know whether you're on the right track or not. So make sure you measure your impact. Collaborate with other people. You can't do everything. I have strengths, I have weaknesses. Sometimes in my team at work, I have to reach out to my colleagues and say, Chai, you are good at this. Can you help me? I don't know how to do this. So collaborate. Be neat and accurate. As someone who's in stats and math, you have no excuse. If you're making a mistake on small things, how can a company trust you to keep its accounts and to report on data accurately? This afternoon, I asked Vincent for some CVs because our HR department is looking for 2 interns to work with me, actually, in my department. I saw someone who had a wrong spelling of the word CV. Guys, if your spelling is wrong, a recruiter is just going to put your CV aside and not even bother opening it. Worse, if you're calling yourself a mathematician or a statistician, you are supposed to pay attention to detail and be accurate. So small things matter, spellings matter. That might be the difference between you getting a job and you not getting a job. They'll just dismiss your CV and be like, there's so many wrong spellings in here. And for maths and stats, we need accurate people. Then also do what comes naturally. Like I'm saying, I enjoy talking. So at work, you'll find I'm the one mainly who will present the results. I have other workmates, they'll do the crunching, the number crunching, but when it comes to presenting, they don't want. But for me, give me that. So what comes naturally to you? Incorporate that in your career. Then be well-rounded. I once met a classmate of mine who was with at NAST, and they were trying to apply for a job. They were asked a simple question, they couldn't even speak. They were so nervous. So if you're good at maths and good at solving problems and coding, but when you go to the interview, you're like, you won't get the job, right? So don't just be a technical person, be well-rounded. Learn how to do public speaking. Learn how to do different things so that you can thrive as someone with a technical background. And then lastly, obviously, NAST motto, think in other terms. That is so true. Be someone who thinks in other terms. Be different from those around you. The good thing with maths and statistics, guys, we are unique because I noticed someone once told me that even for the banking sector, you have a banking degree, commercial degree at NAST, but some banks will actually rather take someone who did maths or stats because they're more accurate with numbers. So the good thing is we are technical, we are intelligent, and we are quick learners. So that sets us apart from the rest. So take advantage of this as you think of your career. Be well-rounded, like I said. Solve problems no matter what industry you end up in. Thank you very much.